I will be reading and testing from this book, which is the Linux command line by William Schutz. And I will not start at the beginning. I will start with pipelines. Pipelines. I think the audio is working. Okay. Pipelines. The capability of commands to read data from standard inputs, also sent to standard output, is utilized by a shell feature called pipelines, using the pipe operator, which is a vertical bar. The standard output of one command can be piped into the standard input of another. Command 1, pipe command 2. To fully demonstrate this, we're going to need some commands. Remember how we said there was one we already knew that accepts standard inputs. Okay, my kid is here. To fully demonstrate this, we're going to need some commands. Remember how we said there was one we already knew that accepts standard input. It's less. We can use less to display page by page the output of any command that sends its results to standard output. So here he's using ls-l use bin, and it pipes that to less. I already have a testing directory. Yeah. That's my shoe. Tack så mycket. And so we can pipe this into a file. First, no wait. Let's. Okay, now we're looking right. You slash bin pipe that into this, and we can browse it with page up and page down. We can search slash help or something. What's next when you do pattern slash pattern search, repeat previous search, so slash is, and then we do n to see, to go to the next one. And what was question mark pattern? No, lägg inte bara. Question mark pattern to search backwards. This is extremely handy. Using this technique, we can conveniently examine the output of any command that uses standard output. Difference between arrow and pipe. At first glance, it may be hard to understand the redirection performed by the pipeline operator versus the redirection operator. Yes, it is. Simply put, the redirection operator connects a command line with the file, while the pipeline operator connects the output of one command with the input of a second command. Simply put, the redirection connects a command with the file. Redirection operator. The pipeline operator connects the output of one command with the input of a second command. Okay. Right. Yeah. The redirection operator is towards a file and the pipe is towards the command. Right. Sometimes something really bad. Okay. CD ls, and he piped the answer of ls into less. The first command put him in the directory command expression stored, and he overwrote the less. Right. Aye. Filters. Pipelines are often used to perform complex operations on data. It's possible to put several commands together into a pipeline. Frequently, the commands used this way are referred to as filters. Filters take input, change it somehow, and then output it. The first one we will try is sort. Imagine we wanted to make a combined list of all executable programs in bin and USR bin, put them in a sorted order, and view the resulting list. Just first ls command, then the sort command, and then the less command. Now they're sorted. What are they sorted by? I'm scrolling with the scroll. Is it alphabetically? Since we specified two directories, bin and his YouTube. The output of else will have considered two sorted lists, one for each directory. By including sort in our pipeline, we change the data to produce a single sorted list. Right. That's cool. So I'll include the current directory. Yeah, I like that. Or can I find one of my files? Out again. That's mine. See, that's one of these. Out again. This is just random stuff. I'm gonna pause the recording to see if everything's working. Okay. Yes, unique. Report or omit repeated lines. The unique command is often used in conjunction with sort. Unique accepts a sorted list of data from either standard input or a single file name argument. See the unique man page for details, and by default removes any duplicates from the list. So to make sure our list has no duplicates, that is, any program from the same name that appears in both the /bin and /user/bin directories, we will add unique to our pipeline. Okay. Let's have a file called, we have a file called cat here. So add cat to dir to cat, and let's do to, yeah, and now ls do to, and here pipe that into unique and cat, only cat once, but here we get cat twice. No, there's cat 2 times here, actually. 2 cats. Why is that? Sort, yes, the sort as well. It has to be sorted first to work. Then it worked. Yeah. Do you need the spaces? No. Huh. But you needed a sort. Otherwise. Alright. Omit repeated lines. Unique except the shortest list of data from either standard input or a single file named argument. See the unique map page for data. By default removes duplicates. In this example, we will use unique to remove any duplicates from the output of the sort command. If we want to see the list of duplicates instead, we add the -d option to unique, like so. Only the duplicates. Nothing. Sort. Cat. Right. WC. I'll add a note here. I'm gonna. Why? Note. Why does it did not work sort? Try to figure that out later. Actually, why not now? Alright, so I asked ChatGPT, actually I did some research, you could say. Unique only works on elements that are next to each other. That's why you need to sort them first. So for example, I haven't done this yet, but I've made this file with a call list of names. It has these names. Look, it has duplicates, but these are not next to each other. So let's try that. Unique list of names. Did not do anything. Did it need to be on? If I sort it then. Sort. There's the names. And then unique. Nothing. Nothing. Let's put them on their own lines. Maybe that'll do something. Right. Yeah. No. Unique. Yeah, look at that. So now you can see the first Alex is only one, but if we sort it, it should be only a single Alex. Yeah, look at that. So unique only works with elements next to each other. WC print line word and byte counts word count. The WC word count command is used to display the number of lines, words, and bytes contained in files. Here's an example. Word count ls output txt. Okay, in this case it prints out 3 numbers. lines, words, and bytes contained in the file. Like our previous commands, if executed without command line arguments, WC accepts standard input. The L option limits its output by only report lines. L for lines. Adding it to pipeline is a handy way to count things. To see the number of items we had in a sorted list, we can do this. So that's the amount of unique items in this. Give it a try. ls bin and user bin sort unique and word count L. 12 are in the 10 unique executables, I guess. Grep. Okay, this one I really want to learn. I've seen this. Grep is a powerful program used to find text pattern within files. It's just like this. Grep pattern file. When grep encounters a pattern in the file, it prints out the lines containing it. The pattern that grep can match can be very complex, but for now we'll concentrate on simple text matches. We'll cover the advanced patterns called regular expressions in chapter 19. Let's say we wanted to find all the files on a list of programs that had the word zip embedded in the name. Such a search might give us an idea of some of the programs in our system that had something to do with file compression. We would do this. ls bin user sort unique grep, and then okay, so he makes the unique list and then he greps zip. Cool. There are a couple of handy options for grep. Grep A. Names with A. I. Names with I. No. Mes. James. Yeah. There are a couple of handy options for grep. -I, which causes grep to ignore case when performing the search, and -v, which tells grep to print only those lines that do not match the pattern. The inverse, basically. Do not match the pattern. Head tail. Okay, that was it. Sometimes we don't want all output from a command. We may only want the first few lines or the last few lines. The head command prints the first 10 lines of a file, and then tail command prints the last 10 lines. By default, both commands print 10 lines of text, but this can be adjusted with the N option. Head 3 less list of names. Yeah. So I could sort them. I can go unique. Sort list of names unique. Yeah, and then do head and 3. Cool. Is that reverse it? Is that reverse it? Sort command? No. Or? Yep. Or reverse sort. This can be used in pipelines as well. Yeah, we did that. Tail has an option which allows us to view files in real time. This is useful for watching the progress of log files as they're being written. In the following example, we'll look at the messages file in the var log or the var log F option. Let's do that. Tail list of names. Oh, F, not big F. Okay, it's running. I'll do a new and we'll append a name. Go Robin into list of names. Yeah, there it is. Cool. Cool. Huh. Will it stop at 10 lines? No, it'll just continue. Control D, no, Control C. If I do N1, just one, but we'll keep writing them. Cool. T, read from STIN and output to STOut and files. In keeping with our plumbing metaphor, Linux program a command called T, which causes a T fitting on our pipeline. The T programs reads standard output and copies it to both standard outputs along the data to continue down the pipeline and to one or more files. This is useful for capturing a pipeline's content at an intermediate stage of processing. Here we repeat one of our earlier examples, this time including T to capture the entire directory listing to the file. Huh. T lst and then grep zip. So all this will go into lst and only this will go into the st output. Cool. Let's do that. Do what? How to put it into file? Cat last name. No, I have to T it, right? Okay, T last name, and then, or it doesn't make sense to just have one, because then output will be the same. It doesn't matter. I want that bit to be the same. No, let's do 10 and grep R. Huh. So grep didn't find anything. Tail. Oh. I forgot the. You shouldn't do that, right? You should have. Or wait, since there's a var variable, you have to have two different, right? List of names like that. There we go. And I'll go out and I'll take a look at last name. Yeah. Yeah, cool. There's this. Here we had the same output too. Standard and the name and the file, but I could have, like if I did grep X, wouldn't match anything. But the file, since we've overwritten it, it still has all the robins. Summing up, as always, check out the documentation of each of the commands we have covered in this chapter. We have only seen the most basic usage. They all have a number of interesting options. As we gain Linux experience, we will say that the redirection feature of the command line is extremely useful for solving specialized problems. There are many commands that make use of the standard input and output, and almost all command line programs use standard L to display their informative messages. Linux is about imagination. When I am asked to explain the difference between Windows and Linux, I often say use a toy analogy. Windows is like a Game Boy. Wow, it's fun. You go to the store and buy one all shiny new in the box. You take it home, turn it on and play with it. Pretty graphics, cute sounds, and after a while though, you get tired of the game that came with it, so you go back to the store and buy another one. This cycle repeats over and over. Finally, you go back to the store and say to the person behind the counter, I want a game that does this, only to be told that no such game exists because there is no market demand for it. Then you say, but I only need to change this one thing, and the person behind the counter says, no, you can't change it. The games are all sealed up in the cartridges. You discover that your toy is limited to the games others have decided that you need. Linux, on the other hand, is like the world's largest erector set. What is that, like Lego or something? Lego. You open it and it's just a used collection of parts. There's a lot of steel struts, screws, nuts, gears, pulleys, motors, and a few suggestions of what to build. So you start to play with it. You build one of the suggestions, then make another. After a while, you discover that you have your own ideas of what to make. You don't have to go back to the store, as you already have everything you want. The erector set takes on the shape of your imagination. It does what you want. Your choice of toy is, of course, a personal thing. So, which toy would you find more satisfying? Chapter 7. End of Chapter 6. Chapter 7 of the Linux command line. Seeing the world as the shell sees it. In this chapter, we are going to look at some of the magic that occurs on the command line when we press the Enter key. While we will examine several interesting and complex features of the shell, we will do it with just one new command. Echo, display a line of text. Echo, hello. Expansion. Each time we type a command and press the Enter key, Bash performs several substitutions upon the text before it carries out our command. We have seen a couple of cases of a simple character sequence. For example, asterisk star can have a lot of meaning to the shell. The process that makes this happen is called expansion. With expansion, we enter something and it is expanded into something else before the shell acts upon it. To demonstrate what we mean by this, let's take a look at the echo command. Echo is a shell built-in that performs a very simple task. It prints a text argument on standard input. Echo, this is a test, this is a test. Pretty straightforward. Any argument passed to echo that gets displayed. Let's try another example. Echo star. And it gets what looks like the output of ls. Go. Yeah. What just happened? Why didn't echo print star? As we recall from our what happened? Echo. Recall from our work with wildcards, the root character means match any characters in a file name, but what we didn't see in our original discussion was how the shell does that. The simple answer is that the shell expands the star into something else. In this instance, the names of the files in the current working directory. Before the echo command is executed. When the Enter key is pressed, the shell automatically expands any qualifying characters on the command line before the command is carried out. So the echo command never saw the star, only its expanded results. Knowing this, we can see that echo behaves as expected. But like star L, does that find anything that has an L? S. Yeah. Anything that ends with S. but if it doesn't exist, it'll echo the okay. Pathname expansion. The mechanism by which wildcards work is called pathname expansion. If we try some of the techniques that we employed in earlier chapters, we see that they are really expansions, giving a home directory that looks like this. We could carry out the following expansion. D, yeah. So I go, but is it just the files or is it the directories? Go D2. No, it's the folders too. Or even this. Echo bracket upper. Okay. It's upper capital letter. And looking beyond our home directory, we could do this. Echo usr star and /share, and we get everything that ends with share. Echo bin. Cool. Echo T, and we get out. Echo L star E star. Pathname expansion and hidden files. As we know, file names that begin with a period character is hidden. Pathname expansion does not respect this behavior, as expansions such as the following does not reveal hidden files. It might appear first that we could include hidden files by using a period. It almost works. However, if we examine the result closely, we see that the names dot and dot dot will also appear in the results. Because these names refer to the current working directory and its parent directory, using these parents will likely produce an incorrect result. We can see this if we try the following command. ls directories dot star into ls. ls d. So just the current directory. ls d star dot star. Yes. No such file directory. It doesn't even match that. To better perform pathname expansion in this situation, we have to employ a more specific pattern. Echo dot and then there's bracket exclamation point bracket star. This bracket expands into every file that begins with only one period followed by any other characters. This will work correctly with most hidden files, though it still won't include file names with multiple leading periods. The ls command with a -a option almost always will provide correct list of hidden files. Tilde expansion. As we may recall from our introduction to the cd command, the tilde character has a special meaning. When used at the beginning of a word, it expands into the name of the home directory of the named user, or if no user is named, the home directory of the current user. The user foo has an account, then it expands to this. Tilde is such a pain to write. It's a directory. Echo. arithmetic expansion. The shell allows arithmetic to be performed by expansion. This allows us to use the shell prompt as a calculator. Go $, and then 2 parentheses. Arithmetic expansion uses the following form, where expression is an arithmetic expression consisting of values and arithmetic operators. If I do, I can't remember how you do var 6 equal to, here we can't have spaces, 6, no, yeah, look at that later. Where expressions is an arithmetic expression consisting of values and arithmetic operators. Arithmetic expansion supports only integers, whole numbers, non-decimals, but we can perform quite a number of different operations. Table 7.1 describes a few of the supported operators: plus, minus, multiplication, division, modulo, the remainder, and double asterisk for exponentiation. Spaces are not significant in arithmetic expressions, and expressions may be nested. For example, to multiply 5 squared by 3, we can use this. Squared by 3. 5 squared by 3. So it's 5 squared multiplied by 3. 75. Single parentheses may be used to group multiple expressions. With this technique we can rewrite the previous example and get the same result using a single expansion instead of 2. Here is an example using the division and remainder operators. Notice the effect of integer division. I go with 5 modulo 2 left over. So 5 divided by 2, 1 is left over. Arithmetic expansion is covered in greater detail in chapter 34. Brace expansion. Perhaps the strangest expansion is called brace expansion. With it we can create multiple text strings from a pattern containing braces. Here's an example. Front ABC back, front A back, front B back, front C back. Patterns to be brace expanded may contain a leading portion called a preamble and a trailing portion called postscript. The brace expression itself may contain either a comma separated list of strings or a range of integers or a single character. The patterns may not contain unquoted white space. Here's an example using a range of integers. That is in the strange echo. Okay, no unquoted white space. And if I add some stuff to the beginning, can I add the number thing? 2, was it 2? 2, 5, and then no. Tycker dessa. Yeah, look at that. A, B. Go. So 1 through 5 times A and B. So 1, first all the ones. 1A, 1B. So 2A, 2B. What if we add another one? X. x, y. First, start with the last one. So 1ax, 1ay, 1bx, 1by, 1a, no, 2ax, 2ay. In bash version 4.0 newer, integers may also be zero padded, like so. So I can do and I get all the numbers with the padding. This is probably good for file names. Reverse order. Oh, you can do letters with A. Can you do from AAA to AAC? That's too many. From A to from AA to A to D. No, you can't. Oh wait, you just do that. Yeah, there you go. Cool. Brace expansions may be nested. Alright, so here we have A and then A, 1, 2, B, 3, 4, B. Then we get A1, 2, B, 3, 4. Cause, yeah, right. Huh. So what that's good for the most common is to make list of files or directories to be created. For example, if we're photographers and had a large collection of images that we want to organize into years and months, the first thing we might do is create a series of directories named in numeric year, month format. This way, the directory names would start in a chronological order. We could type out a complete list of directories, but that's a lot of work and it's error prone. Instead, we can do this. Let's do it. Make dear photos. I'll go into photos. And then make dear, and we'll do 2000 until 2024, and we want all the months, so we want 01 to 12, no, 01 through 12. Bam, and then we go, we have all these folders. Cool. Pretty slick. Parameter expansion. We're going to touch only briefly on parameter expansion in this chapter, but we will be covering it extensively later. It is a feature that is more useful in shell scripts than directly on the command line. You see how long you've been? 60 minutes. Many of its capabilities have to do with the system's ability to store small chunks of data and to give each chunk a name. Parameter expansion. We're going to touch briefly on parameter expansion in the chapter, but we'll cover it extensively later. It's a feature that is more useful in shell script than directly on the command line. Many of its capabilities have to do with the system's ability to store small chunks of data and to give each chunk a name. Many such chunks, more probably called variables, are available for our examination. For example, the variable named user contains our username. To invoke parameter expansion and reveal the contents of user, we would do this. Echo user. If we just do that, then the command is found. Print and pipe int less. This is probably not safe. No, it's nothing. I won't look more into it in case there's some. I don't know. You may have noticed that with other type of expansion, if we mistype a pattern, the expansion will not take place, and the echo command will simply display the mistype pattern. With parameter expansion, if we misspell a variable of a name, the expansion will still take place, but will result in an empty string. Command substitution. Command line substitution allows us to use the output of a command as an expansion. Go. Let's. Wait. Why the name like that? That's not right. I didn't even notice when I made the folders. That's not right. Let's remove all the directories. It's a directory. I can't remember. How did you remove empty directories? Help. Force. Dear D. RM. Wildcard D. That's empty. Make dir. Take up the old command. Should be that. Let's see. Yeah, there we go. Cool. Let's echo these. Echo. That's the same as just doing echo. Echo star. Yeah. One of my favorite goes something like this LSL and then which CP. Here we pass the results of which CP as an argument for the ls command, thereby getting the listing of the CP program without having to know its full name. Pathname. So the which CP outputs the file name of that command. Okay, that's your favorite. Why do you need that? Okay. Man, I need the path name for the copy program. Getting the list of a CP program without any full name. We are not limited to just simple commands. Entire pipelines can be used. Only partial output is shown here. LS. Entire pipelines can be used. Partial. So here we go. File. And then we expand LSD for the current directory of USR bin, so all those ones, and pipe that into grep zip. Why is it structured like that? LSD, and then all the folders of USR bin, or what? LSD USR bin. Like that. Are these folders? What does it mean if it's green? Unzip. This is are these all folders? Let's do the L. ls ld user bin, and we'll do piping it ahead so we don't have to see all of it. Okay, these are files. I don't know why not just without the D and without the star. I feel like they cancel each other out. Grep zip, and he gets all files that have zip in them, and he can see what they are. Isn't that the same as typing it? We'll try this first. File ls, and I'll just go user bin instead of the D, and then put that into grep zip like that. No such file or directory. What's that? If I do the D, does it work? Is that why I did it? Bin. Yeah, then it worked. Why is that? Why is that? Let's echo it. Echo. Okay. Okay. So like a list of these, and without it, what do we get? Okay, we don't get the complete path, but I mean that isn't what D did, is it? D directory, list directories themselves, not their contents. So that's so weird because we use D here. Right. This is not a list of file, but a list of direct. This is when it's the directory. So you, okay, so it's like you treat the file as a directory to get the file, the entire file. Path lsd. Okay, that didn't do it. lsd current directory /star. Okay, yeah, then we but if we don't have a and if we do current directory, we get the current directory. You can do the long. Okay, that's weird. That's a weird way of using it, but it works. So if you need the entire relative, or it won't be relative if you put it in an absolute path. If you need the path, you do D, because then you can D and star, I guess. I'm gonna ask ChatGPT about this. Print this whole thing. We'll upload it. New. Upload screenshot. This weird way of getting an entire path using D and then the wild card. The command ls/d user bin star shown in the image is not a weird way to get the entire path. It's actually a common method used in Unix-like operating systems for listing directory entries matching a pattern. This /d options tells ls to list directories themselves, not the content. The wildcard star is used to match all entries in the specified path, which in this case is USR bin. The command will list all files and directories inside the USR bin, but only their names, not the contents of these directories. Yeah, all files and directories. It's often used in script or command pamphlet where you need to work with the names of files and directories, perhaps to process them with other commands. The -d option can be useful when you want to apply ls to directories themselves. Without -d, ls USR bin will list all the contents of all directories inside USR bin recursively. The -d option can be useful when you want to apply ls to directories themselves. Without -d, ls USR bin list all the contents or directories inside recursively. It would? ls. Yeah, look at that. I did not know. That's useful. Which is often not the desired behavior when you're interested in the directory names or in specific file names. But why is it listing files if D is for directory? The ls command with the -d flag in Unix systems is indeed meant to list directory names rather than the contents. However, when used with a wildcard, the behavior might seem counterintuitive at first. The command ls-d USR bin wildcard uses the wildcard character to match all entries in that folder when ls is followed by -d and a list of file and directory names, which is what the wildcard expands to. Right. ls-d will list the names of these files and directories without appending their contents. It doesn't filter out files and only lists directories. It simply prevents the listing of the contents of directories. In simpler terms, ls-d says list the name of the directory itself, not its contents. In simpler terms, ls-d says list the names of the directory itself, not the contents. When combined with a wildcard, it treats both files and directories matched by the wildcard as if they were directories, meaning it lists their names only, not the contents, even if some of the matched names happen to be directories. If you only want to list directories inside USR bin, you would use a command like ls-d and then put a slash at the end. With trailing slash after wildcard is convention used in shells like bash to match only directories. Alright, well. And why is it a grep? Yes, right. In this example, the result of the pipeline became the argument list of the file command. There is an alternate syntax for command substitution in all the shell programs that is also supported in Bash. It uses back quotes instead of the dollar sign and parentheses. ls-l, and then he does back quote which CP. And he gets still the same quoting. Now that we've seen how many ways shell can perform expansions, it's time to learn how we can control it. Take, for example, the following. This is a space test, and you can't see the spaces. Or this one. Echo, the total is $100.0, and the $1 is expanded to nothing. The total is 0. So for a first example, word splitting by the shell removed extra white space from the echo command's list of arguments. In the second example, parameter expansion substituted an empty string for the value of $1 because it was an undefined variable. The shell provides a mechanism called quoting to selectively suppress unwanted expansion. Double quotes. The first type of quoting we'll look at is double quotes. If we place text inside double quotes, all the special characters used by the shell lose their special meaning and are treated as ordinary characters. The exceptions are $, backslash, and back quote. This means that word splitting, pathname expansion, tilde expansion, parameter expansion, brace expansion, arithmetic expansion, and command substitution are still carried out using double quotes. Using double quotes, we can cope with file names containing embedded spaces. Say we were the unfortunate victim of a file called 2words.txt. We tried to use this on a command line. Word splitting would cause this to be treated as two separate arguments rather than a single argument. Yeah. I'm just gonna make a note of this. This is probably very useful. Highlight it. Highlight. Put in a bookmark. ls-d like that. Now let's see, 2 words. Let's make a file. Touch 2 words. This 2 words. Just write something into. Wait, how do you do that again? Echo this into 2 words. Head 2. Right. We can never repair the damage. we can rename it. There. Remember, how can we? Let's say I had a lot of these. Let's make a lot of them. Let's do. Let's go into dir 2. Dir 2. And we'll touch 1 through 10. spaces in this file. And then one of these. Yeah. So I wanted to make all these spaces into underscores. How could we do that? We use the move command, right? Move. But we have to take all the files with spaces in them. How do we find all the files with spaces in them? Find space. Does that work? No. Like that. Echo. Echo. Yeah. There you go. That's all the files with spaces in them. And then we want to... No, I don't know how to do this, because we can't just rename all of them. We have to take the file name and yeah, let's save it to later, for later, by using double quotes. There what is it doing now? Remember, arithmetic expansion, and command substitution is still to take place within the double quotes. So yes, this thing here going. Cal. I don't have cal. Command not found. It looks cool though. Sudo apt install cal. I wrote the wrong password. I can't even find it. Okay. By the default, word splitting looks for the presence of spaces, tabs, and new lines, line-free characters, and treat them as delimiters between words. This means unquoted spaces, tabs, and new lines are considered to be part of the text. They serve only as separators, since they separate words into different arguments. Our example command line contains a command followed by 4 distinct arguments. If we add double quotes, word splitting is suppressed and embedded spaces are not treated as delimiters, rather they become part of the argument. Once double quotes are added, our command line contains a command followed by a single argument. The fact that new lines are considered delimiters by the word splitting mechanisms causes an interesting, albeit subtle, effect on command substitutions. Consider the following. Yeah, look at that. He just prints every word, so to speak, after one another. In the first instance, the unquoted command substitution resulted in a command line containing 38 arguments. In the second, it resulted in a command line with 1 argument that included the embedded spaces and new lines. Single quotes. If we need to suppress all expansion, we use single quotes. Okay, so they're like more extreme. Here is a comparison of unquoted, double quoted, and single quoted. Here it goes A and B, echo foo. Okay. Is this a list of what to echo? Echo text, echo home folder, echo A and B, echo foo, echo for, and echo user. Okay. And here he uses the quotes. You get it all. This will expand. And here he does the single quotes and you just get the exact verbatim text. My kid is tired. He's gonna sleep. Where were we? Yeah. As we can see, with each succeeding level of quoting, more and more of the expansions are suppressed. Sometimes we want to quote only a single character. I'm tired too. It's noon though. To do this, we can precede our character with a backslash, which in this context is called the escape character. Often this is done inside double quotes to selectively prevent an expansion. Yeah, so you escaped this character. It's also common to use escaping to eliminate the special meaning of a character in a file name. For example, it is possible to use characters in file names that normally have special meaning to the shell. This will include these and others. To include a special character in a file name, we can do this. So you can do like Dutch bad file. Escape the escape the space. To allow a backslash character to appear, escape it by typing \\. Note that within single quotes, the backslash loses its special meaning and treated as an ordinary character. Backslash escape sequences. In addition to its role as the escape character, the backslash is also used as part of a notation to represent certain special characters called control nodes. The first 32 characters in the ASCII coding scheme are used to transmit command to teletype like devices. Some of these codes are familiar: tab, backspace, line feed, and carriage return, while others are not. Null, end of transmission, and acknowledge. No, I have not heard about these. Null, what? In addition to row, backslash used to represent special characters. Ja, stänger du där? The table above lists some of the common backslash escape characters. Originally in C program language, and it has been adopted by many others, including the shell. Adding the -e options to echo will enable interpretation of escape sequences. You may also place them inside $, single quote. Here, using the sleep command, a simple program that just waits for a specified number of seconds, then exits, we can create a primitive countdown timer. Sleep 10 echo -e times up \a. And that's a bell. We could also do this.
Pappa.
Yeah.
Pappa. Vad är jättekul.
Ja, gå och lägg dig, älskling. Okay, what would this do? You adding E would enable interpretation of escape sequences. You may also place them inside. Okay, right. Let's try it. Sleep. Let's do 5. Echo times up \a. 1, 2, 3, 4. Forgot the E. Total silence. I don't know. I don't really like that sound anyway. And the other one you could do if it was all in single quotes, then of course you have to do that, I guess. Would that work? Yeah. Summing up, as we move forward with using the shell, we find that expansions and quoting will be used with increasing frequency, so it makes sense to get a good understanding of the way they work. In fact, it could be argued that they are the most important subject to learn about the shell. Without a proper understanding of expansion, the shell will always be a source of mystery and confusion, with much of its potential power wasted. Further reading: the Bash man page and the Bash reference manual. Okay. I think I'll end there. End of chapter 7 of the Linux command line by William Schutz.